Welcome to Section 3.4 APIs and Inference Gateways. In modern AI systems, most models aren't embedded directly in applications. Instead, they're accessed through APIs and inference gateways that handle requests, enforce controls, and ensure performance at scale. By the end of this lesson, you'll be able to explain the roles of APIs and inference gateways in AI deployment, understand mechanisms like rate limiting, throttling, batching, and handling cold starts, describe key responsibilities of gateways including authentication, observability, and caching, and connect these concepts to real-world challenges in scaling AI applications. So API and AI inference. An API, or Application Programming Interface, serves as the contract between your AI model and the outside world. Instead of embedding a model directly, applications make standardized API calls, often HTTP or gRPC, to send input data and receive predictions. This approach abstracts away from the complexity of the underlying model infrastructure, allowing developers to integrate AI without needing to know its internals. APIs also provide consistency. Multiple applications can use the same endpoint, making scaling and upgrades easier. In short, APIs transform machine learning models into usable, production ready services that align with modern software practices. APIs serving AI models must manage demand carefully. Rate limiting and throttling are the primary controls. Rate limiting sets a maximum number of requests allowed within a given time frame. For example, 100 requests per minute per user. Throttling is the active enforcement of that limit, either by delaying or rejecting requests once thresholds are exceeded. These mechanisms prevent abuse, safeguard infrastructure from traffic spikes, and ensure that no single client monopolizes resources. Without these controls, AI inference systems could become unstable or unavailable, especially under heavy load or during peak usage periods. Batching and cold starts. To optimize performance, inference gateways often implement batching, grouping multiple requests together before processing them through the model. Batching increases efficiency, particularly on GPUs or TPUs, where parallelism can be leveraged. However, developers must balance throughput with latency. Waiting too long to batch requests can frustrate users. Another operational challenge is cold starts, which occur when servers spin up new instances to handle demand. Cold starts Cold starts introduce noticeable delays, especially in serverless or containerized environments. Mitigation strategies include pre-warming instances, maintaining a minimum number of active workers, or using adaptive scaling policies to ensure responsiveness. Inference gateway responsibilities. Inference gateways do more than forward requests. They enforce authentication and access control, ensuring only authorized users or systems can consume the model. This is critical for protecting intellectual property and preventing misuse. They also provide observability, metrics, logs, and traces that help operators monitor performance, detect anomalies, and troubleshoot issues quickly. Finally, gateways can employ caching, storing frequently requested results to reduce redundant computation and speed up responses. This is especially valuable for models that are resource intensive or serve repeat queries. Together, These responsibilities position gateways as the guardians of reliability, security, and efficiency in AI production environments. All right, as we've seen, APIs and inference gateways are fundamental to deploying AI at scale. They provide a standardized access point while also shielding the underlying models from unpredictable or malicious traffic. Rate limiting, throttling, batching, and strategies to manage cold starts are all work together to balance performance and fairness. Meanwhile, gateways uphold security through authentication, deliver reliability with observability, and improve efficiency through caching. These are not optional extras. They are the backbone of dependable AI services. Understanding them equips you to design and manage systems that remain stable, secure, and responsive under real world conditions. So, this concludes our discussion on APIs and inference gateways. I look forward to seeing you in the next lesson.